All right, so the solution to the last problem looks like this. You must, if the temperature is not in Kelvin, you must convert the temperature to Kelvin. So these two temperatures we started with, 22 degrees C and minus 12.5 degrees C, had to be converted to Kelvin. To do that, we added 273.15 to both of those, and we get these numbers, and we have to round them off using the same system you've been taught for rounding off in addition and subtraction you've learned all semester. Then we just put all of our numbers in the list of knowns and unknowns, found the equation that fits that list, and solved the way you were taught before. Just plug in the values you have, isolate the unknown, solve for the answer. What? Yes, yes. Okay, so her question is, can you make your list of knowns and unknowns before you do the math here and list both of them? So you would say T1 equals 22.0 degrees C, and then say that also equals 295.2 K. Yes, you can do that. That's perfectly okay. That's the way I do it a lot of the time. Okay? Any other questions about that? All right, then. Let's go to this. This is a different situation. I didn't give you temperature in Celsius here. I gave it to you in Kelvin because we got a different problem with the solution here that I find a lot of students are confused about. It's something you probably should know from algebra. And if your algebra teacher were watching this, they'd say, well, I taught them that. They'd be highly disappointed, but it comes up. So here's what I want you to do. I want you to listen to me carefully. I want you to do all the problem solution steps up to the point where you isolate the unknown, but don't do the isolation step. You got it? Solve everything up to the point where you isolate the unknown, but don't put in the isolation step. Got that? Okay, you do that, and then we'll pick it up from there. All right, listen up. Now here's what, this is where your algebra teacher is going to be sad right now, okay, because I have to tell you this. You cannot solve for a variable on the bottom of a fraction directly. It has to be on the top of a fraction. We're going to get the reciprocal of both sides. As long as you do the same thing to both sides, you can do that. So you flip both sides, okay? Flip both sides. Do that now. Flip both sides. Okay. Now we've got the unknown on the top of the fraction, and we can solve it the way we did before. All right, it's real simple. Just remember, you cannot solve for an unknown or cannot solve for it directly for an unknown if it's on the bottom of a fraction. You got that? Everybody clear? So you got to flip. See, wrestlers understand this very well. Because if you're on the bottom in wrestling, you want to try to flip. What?
Wow.
Yes. Yeah, but if the four-wheeler's on top of you, I doubt you can. Yeah, that'd be kind of tough. Yes, you do. So this number here has 3 digits, and this one has 3. So we got to have 3 digits in this answer. So we're going to round off that last digit. And here's a question and the answer really to a question that Joseph was asking a while ago. Do we ever have an answer that doesn't have any decimal places? Well, there it is. Sure. All right, we're going to practice this problem now. 50 liters of oxygen at 195.0 Kelvin is what it should be, sorry. Has its temperature lowered to the point where the volume is 40.0 liters. What is the temperature? No. In gas laws, it's not really necessary to show the species. You end up with a species everywhere, and it all cancels out. You could if you want to, wouldn't hurt anything. No. Depends on what the question is asking. Since the question is only asking about oxygen, just telling me the volume is fine. Wouldn't hurt to do it. Can't hurt ever.